As we look at the landscapes of our planet, one question arises. Is there another planet somewhere in the universe with conditions similar to ours? But to find the answer to this question, it is not necessary to look at some far corners of the universe. Because there is a partial answer to this question in the planet that is the closest neighbor of our planet. Yes, we are talking about the planet Vinera. The planet Vinera is believed to have once had liquid water oceans and a temperate climate. The current Vinera atmosphere is richer in primordial noble gases compared to Earth's atmosphere, and this enrichment suggests that the planet was separated from the composition of the planet early in its evolution. Research has shown that billions of years ago, Vinera's atmosphere may have been more similar to the atmosphere surrounding early Earth, and suggests that its surface may have had large amounts of liquid water. If Vinera had a favorable climate and abundant liquid water bodies at the beginning of its evolution, how did it become such a hot and barren atmospheric desert? There are two hypotheses about this. The first is that Vinera is definitely very close to the Sun. It is inferred that the increasing brightness and temperature of the Sun caused the water in Vinera's reservoirs to completely evaporate. According to the second hypothesis, these are volcanoes. We can say that Vinera is a planet of volcanoes. There are so many volcanoes in Vinera. 167 large volcanoes have been found on the surface of Vinera. The only volcanic complex of this size on our planet is the Big Island of Hawaii. More than 85,000 volcanoes have been identified and mapped in Vinera. We know that volcanoes release large amounts of carbon dioxide into the planet's atmosphere, causing the temperature to rise. As a result of this process, over time the air temperature reaches its current state. Currently the average surface temperature of Vinera is 453 degrees centigrade. At such a high temperature, it is inconceivable that liquid water pools would exist on Vinera's surface. The fact that the temperature is too high is not the only problem in Vinera. There is also the atmospheric pressure. Venus' atmosphere has a pressure of 9.3 megapascals, which on our planet only exists in the oceans almost a kilometer deep. Thermal inertia and the transport of heat by winds in the lower atmosphere mean that despite Venera's slow rotation, Venera's surface temperature does not differ significantly between its two hemispheres, the Sun-facing and non-Sun-facing hemispheres. For example, because Mercury does not have an atmosphere like Venus, the temperature on the sunward hemisphere rises to 427 degrees centigrade. And the temperature on the dark side cools to -170 degrees centigrade. In this regard, Venera's atmosphere is very similar to that of our planet due to the greenhouse effect. Due to the density of the atmosphere on the surface of the planet, winds blow very slowly, moving at a speed of only a few kilometers, but due to the high density of the surface of the atmosphere, they exert considerable pressure on obstacles in their path and transport dust and small stones along the surface. This process exacerbates the harsh conditions that occur due to high temperatures and strong atmospheric pressure on the planet's surface. While Venusaur's surface conditions are harsh at this level, conditions 50 kilometers above the planet's surface are quite different, because at this altitude the temperature ranges from 30 degrees centigrade to 80 degrees C, and the atmospheric pressure and radiation are the same as our planet's, but this layer has acid clouds and carbon dioxide air similar to our planet's. Not the same. The influence of the dense atmosphere of Vinera is very noticeable in one other case. Associated with asteroids and meteorites, Vinera has nearly 1,000 impact craters that are evenly distributed across the planet's surface. Vinera impact craters range in diameter from 3 kilometers to 280 kilometers. Due to the impact of the dense atmosphere on incoming objects, there are no impact craters smaller than 3 kilometers on the surface of the planet. Objects with less than a certain kinetic energy are slowed down enough by the atmosphere that they do not create impact craters. For this reason, objects smaller than 50 meters in diameter disintegrate and burn up in the atmosphere before reaching the planet's surface. About 85% of the craters in Vinera are clean and intact. Craters on Earth and the Moon have experienced a series of disruptions. Decaying craters on the Moon were caused by subsequent impacts or other impacts, and the lack of an atmosphere on the Moon was the same period. The destruction of craters on our planet is caused by wind and rain erosion. One of the reasons why most of the craters on our planet are invisible to us is that the tectonic plates on the planet have changed the surface of the planet as they move, and over millions of years. Water and winds have moved soil over the craters, causing a thick layer of sediment to form on top of the craters. At the top of Venera's atmosphere, the wind speed increases, that is, at a speed of 300 kilometers per hour, non-stop winds blow across the surface of the planet. Unlike our planet's semi-cloudy atmosphere, Venera's surface continues to be filled with high-velocity winds, constantly blowing the clouds away. As a result, Venera's surface appears full and white, rather than partially cloudy like our planet's surface, and in a way, it's a pretty sight. As we said, the temperature and pressure 50 kilometers above the surface of Venera are very close to those of our planet. Some scientists and experts have hypotheses about creating conditions for human habitation in this layer of Venera. According to these hypotheses, it is envisaged to establish flying cities with a closed environment in this layer of Venera, and it would be desirable for these flying cities to be mainly in the form of dribbles, so that it would be easy for them to stay at a certain height. But in order to work on such expensive projects, we still have to go through some difficult steps. Because right now, at a time when most of the population of our planet is experiencing economic difficulties, projects that require such large expenses will naturally have to stay on paper or in dreams for an indefinite period of time. Most of the clouds on our planet are mostly in cyclones. This situation is different in Venera because the cyclones move in a circle. The clouds on Venera's surface are moved in an almost straight line by the winds. As a result, clouds move around the planet very quickly. It only takes 4 or 5 days for the clouds, driven by strong winds, to completely circle the planet. This planet, which lost its favorable conditions, in other words, its liquid water basins and temperate climate, many years ago, we still love this planet despite its dire situation. Because any thinking person who sees this situation knows very well that our beloved planet is perfectly in its position.